Hello and welcome to the Manifested e-learning platform. We will continue with the study of advanced financial management. In this lesson, we're going to learn how to calculate two things. Number one, the simple Macaulay duration and the modified duration. We will first of all define the simple Macaulay duration. We get into the properties of Macaulay duration, then we will work out a past paper question. We do the same for the modified duration. So we start with the simple Macaulay duration. The simple Macaulay duration, which, as the name suggests, is a concept that is attributed to a gentleman known as Robertson Macaulay. So the concept of Macaulay duration is attributed to Frederick Robertson Macaulay. He was an economist who introduced the concept of bond duration. So his work, particularly in the 1930s, laid the foundation for understanding bond sensitivity to interest rate changes. So the Macaulay duration is the weighted average length of time to the receipt of a bond's benefit. And the bond's benefit comprise of the coupon and the redemption value, and the weights being the present value of the benefits involved. So the average time taken to recover the cash flow from an investment is not only affected by the maturity date of the investment, but also by the coupon rate, which determines the interest payment. So duration gives each bond an overall risk weighting. Do you understand? That allows two bonds to be compared. And in simpler terms, it is a composite measure of risk expressed in years. That's why we get the word duration. So duration is the weighted average. It's the weighted average length of time to the receipt of the bond's benefits, which comprises of the coupon and the redemption value, and the weight being the present value of the benefits involved. That's the meaning of the simple Macaulay duration. It is the average number of years that an investor will wait until the investor receives the benefits, which comprises of the coupon and the redemption value. Now, in this lesson, again, we're going to discuss the properties of the simple Macaulay duration. Properties. What are the properties? Properties, as we all know, are just the characteristics or the attributes. Characteristics or the attributes. The first property of the Macaulay duration is the weighted average time. Weighted average time. Number one, weighted average time. That's the first key property. Weighted average time. Macaulay duration measures the weighted average time until a bond's cash flows are received. So the weighting, we know, is based on the present value of those cash flows. 2, relationship with maturity. Relationship with maturity is the second property. Generally, Macaulay duration increases the bond's maturity, and for example, for a zero coupon bond, the Macaulay duration is equal to its maturity. This relationship with coupon rate. Relationship with coupon rate is a third property. Macaulay duration is inversely related to the coupon rate, such that higher coupon rates lead to shorter Macaulay durations as more of the bond's value is received earlier, because it is received earlier. Moving on to the third property, the fourth property, number 4, relationship with yield to maturity. Relationship with yield to maturity is the fourth property of simple Macaulay duration. Relationship with yield to maturity, the YTM, yield to maturity. So Macaulay duration is generally inversely related to the yield to maturity, because as the yield to maturity increases, the present value of future cash flows decreases, and therefore the Macaulay duration decreases. 5, cash flow focus. Cash flow focus is the fifth property. Cash flow focus. Cash flow focus. Now, it specifically measures the time it takes to recover the bond's cash flows, considering their present values. 6, unit of measurement. We can describe the property of a simple Macaulay duration by looking at the unit of measurement. Macaulay duration is expressed in units of time, typically years. So these are 5 plus 1 properties. That is number 1, property related to weighted average time. Number 2, relationship with the maturity. Number 3, the relationship with the coupon rate. Number 4, relationship with yield to maturity. There is a cash flow focus and the unit of measurement. Unit of measurement. So in essence, candidates, Macaulay duration provides a time-based measure of a bond's cash flows, highlighting how factors like maturity, coupon rate, and yield to maturity influence the timing of those cash flows. That's it for the properties. Now we are going to take time to answer a question that was tested in December 2023. We're going to work out this question. December 2023 question 3C reads as follows. A bond with a maturity year to maturity has a current value of 92 shillings and 41 cents, a coupon rate of 8% per annum, and current market yield of 10% per annum. The bond will be redeemed at par value of 100 shillings. The bond will be redeemed at a par value of 100 shillings. Required, using the Macaulay duration, compute the bond's duration. Compute the bond's duration. And candidates, we've defined the Macaulay duration as the average time taken to recoup the benefits of the bond, which comprises of the coupon and the redemption value. So this is a question that was tested in December 2023. So we're going to calculate the bond's duration using the Macaulay duration method. So what is the duration? Illustration. This is a question that was tested in December 2023. Question 3C. Now, using the Macaulay duration, we know the formula. The duration is equal to the sum of present values of cash flows, the sum of present value of cash flows. We take the sum of the present value of cash flows, divide by the market value of the bond. divided by the market value of the bond. And this we multiply. Allow me to rub this part. Sum of present value of cash flows multiplied by respective years. Multiplied by respective years. Now look at the question. The question reads, a bond with a 5-year to maturity. The bond has a current value of 92 shillings and 41 cents. The coupon rate is given at 8% per annum, and there's a current market yield of 10% per annum. So we're going to have a working. So what we do here, we'll have just one working. Now that we have the formula. To calculate the duration, we get the sum of present value of cash flows, and we know the cash flows will comprise of the coupon, the interest, and the redemption value. So we have the cash flows at the end of every year. And there are how many years here? We have 1, 2, 3, 4, 5. As read in the first sentence, a bond with a 5-year to maturity, a bond with 5-year to maturity. Then the next column here is cash flows. We have a column for cash flows, and these cash flows are in shillings. How do we determine the cash flows? The cash flows, I've said, comprise of two things. This is a bond, and the investor here will be receiving interest of 8%. The interest is 8%. The interest is 8% per annum. 8% per annum is the interest, and therefore the interest in shillings will be 8% of the par value of the bond, which is 100. So 8% of 100 shillings is 8 shillings. So at the end of every year, the investor will be receiving 8 shillings. 8 shillings, 8 shillings, 8 shillings. Until the 5th year, when the investor will recoup the par value of the bond plus the interest, which will be equal to 100 shillings plus 8 shillings, being equal to 108. So these are the cash flows. At the end of year 1, there is 8 shillings. At the end of year 2, 8 shillings. At the end of year 3, 8 shillings. At the end of year 4, 8 shillings. Then at the end of year 5, this is when the bond is to be redeemed. The investor will get back the 100 shillings that was invested plus the interest for the 5th year, which will be 8 shillings plus 100 shillings. Plus 100 shillings. Then we get the present values. We discount these values. Present values. We discount the present values. And this we read. To discount the present values, we need the present value interest factor. Present value interest factor. What is the present value interest factor? Present value interest factor we read now from the tables. We get to the tables. Present value interest factor, the interest is 10%. The number of years is, this is 10% N. 10% N. This one is easy to read from the tables. Now reading from the tables, at the end of year 1 is 0.9091. 0.9091. The present value interest factor year 2 will be 0.8264. 8264. From the table again, we have 7513. 7513. Year 5 is 6830. 6830. That is the 4th year. The present value interest factor for the 5th year is 6209. 0.6209. So these are the present value interest factors, which you are going to multiply with the cash flows to get the present values. So we have a table here for the present value. So this is called discounting. We discount these cash flows. So we are going to take 8 multiplied by 0.9091. 8 times 0.9091, 7.2728. Next, 8 times 0.8264. 8 times 0.8264. 6.6112. Next, we have 8 times 0.7513. 6.0104. Next, 8 times 0.683. 5.464. And lastly, we discount 108 times 0.6209. 67.0572. Then we get the sum, because the duration is equal to the sum of present values of cash flows. The sum of present value of cash flows. These are the present value of cash flows. These are the present value, so we get the sum. The sum, okay? We get the sum. So what is the sum? What will be the sum? The sum, we multiply by the time. Remember, we have the respective years. We have the respective years. Before we get the sum, the summation, we have to get the product of the present value of the cash flows and the respective years. So respective years, we're going to get this present value times time. We have another column. Before we get the sum, we have another column here. So this sum here is what we are looking for. So it is the sum of present value of cash flows times respective years, the time. So the first instance, we are going to take 1 times the present value of cash flows of 7.2728, which is equal to 7.2728. Next will be 6.6112 times 2. 2 times 6.6112. This gives me 13.2224. Next, we'll multiply these present values, the present value of cash flows of 6.0104, this value, times time, 3 years, times 3, 18.0312. Next, we have 5.464, 5.464 times 4, 21.856. Lastly, 67.0572 times 5, 335.286. So you go ahead and get the sum. Get the total here, 7.2728 plus 13.2224 plus 18.3 18.0312 plus 21.856 plus 335.286. 395.6684. So 395.6684 is the sum of present value of cash flows and times the respective years. So this is the sum. We took the respective years and multiply with the present values to get the sum. That is the numerator, which is equal to 395.6684. We divide by the market value of the bond. The market value of the bond is given within the question. We read in the first sentence, the current value of 92.41. 92.41 is the market value of the bond. So we get the answer there. This will be equal to answer divide by 92.41. So my answer here is 4.28 years. That is the simple Macaulay duration. The period is, or the duration is 4.28 years. 4.28 years. Now, a Macaulay duration of 4.28 years signifies the weighted average time it takes for an investor to receive the bond's cash flows, and in simpler terms, it indicates the average time until you get back your money. So if an investor, for example, this investor we read, a bond with a 5-year to maturity has a current value of 92.41. The coupon rate is given 8%. The current market, the yield is also provided. So the question is, how long will it take for this investor to recoup back the money that was invested with the par value of the bond of 100 shillings and the coupon payments or the interest payments? So the simple Macaulay duration here is 4.28 shillings. It's going to take 4.28 shillings to recoup back the money, to receive back the money that was invested in this bond. And that's all for the simple Macaulay duration. Now, candidates, allow me to proceed to the modified duration. In this lesson, the second objective was to learn how to compute both the simple Macaulay duration and the modified duration. Modified duration. Modified duration. Modified duration. Modified duration, candidates, is a measure of the sensitivity of the price of a bond to change in interest rates. It is the measure of sensitivity. It is a measure of sensitivity of the price of a bond to change in interest rates. Do you get it? It is a measure of sensitivity of the price of a bond. First of all, it is a measure of sensitivity of price of a bond. How sensitive is the price of a bond to change in interest rates? To change in interest rates. How sensitive? If there is change in interest rate, how does it affect the price of a bond? If the interest rate increases or reduces, how does that increase or decrease affect the price of a bond. Now, rather than just looking at the weighted average time it takes to receive a bond benefits, modified duration measures how sensitive the price of the bond is to change in the interest rates. And just like we did in the simple modified, the simple Macaulay duration, we are going to highlight the properties. What are the characteristics of modified duration? What are the characteristics? The first characteristic is in relation to measure. It measures price sensitivity. That's the first feature. It measures price sensitivity. Number one, measures price sensitivity. Modified duration, number one, it measures, number one characteristic, it measures the price sensitivity. The duration directly quantifies the percentage change in the bond's price for a 1%, 100 basis points change in its yield to maturity. And that is its primary function. Measuring price sensitivity to change in interest rates. The second feature is that the modified duration is derived from Macaulay duration. Derived from Macaulay duration. And shortly we'll be looking at the formula. The denominator will be the Macaulay duration. First of all, calculate the Macaulay duration. So that's the first thing to note. It's derived from Macaulay duration. It's calculated by adjusting the Macaulay duration, which makes it more practical measure of price volatility. And the formula, which we'll be looking at shortly, will reflect this relationship between the modified duration and the Macaulay duration. 3, inverse relationship. There is an inverse relationship with yields. Okay? Yields. Inverse relationship with yields. Inverse relationship with yields. Inverse. Now, like all bonds duration measures, the modified duration reflects the inverse relationship between bond prices and yields, so that when yields rise, bonds prices fall and vice versa. And this modified duration then helps us to estimate the extent of that change. 4, approximation of price changes. How is it a feature? Approximation of price changes. Now, it provides an approximation of how a bond's price will relate or react to yield changes. But it's important to note, as we discussed earlier on, that it's a linear approximation of non-linear relationship, which makes it yet again a limitation. It is used to approximate the changes in price of bonds. Now we can do another property or characteristics, which is the influence of bond characteristics. Influence of bond characteristics. Influence of bond characteristics. Influence of bond characteristics. Now, like Macaulay duration, modified duration is affected by bonds maturity, by the coupon rates, and also the yield to maturity. Understand? Such that longer maturity generally leads to a higher modified duration, and the higher coupon rates typically results in a lower modified duration. So higher yield to maturity usually leads to lower modified duration. 6, used for risk. It is used for risk management. Investors use modified duration to assess and also to manage the interest rate risk of their bond portfolios. That is to say that it helps them to understand how their bond holding might be affected by changes in interest rates. So these are 6 characteristics of modified duration, which you have defined to be a measure of sensitivity of price of a bond to change in interest rate. So the first feature here is in relation to price sensitivity. It measures price sensitivity. Number 2, it is derived from Macaulay duration. Number 4, it has an inverse relationship with yields. Number 4, approximation of price changes. It may use to approximate price changes. Number 5, it has an influence of bond characteristics. And lastly, it's used for risk management. Now let's move on to answer one past paper question. It's a question associated with the Wasili Limited. I read, Wasili Limited has a bond A in issue which has a nominal value of 1,000 shillings and is redeemable at par. Bond A is a 6% bond maturing in 3 years time and has a gross redemption yield of 3.5%. The current price of the bond is 1,000 shillings, 1,070 shillings and 12 cents. Required, calculate the modified duration of the bond. Illustration. Now we are required to calculate the modified duration of the bond. The modified duration of the bond. The modified duration of the bond. So modified duration, what is the formula? Modified duration, we know the formula is equal to Macaulay duration. We first of all calculate the Macaulay duration, and you recall here we say that it is derived from Macaulay duration. So before calculating the modified duration, first of all you have to calculate the Macaulay duration, because modified duration is derived from Macaulay duration. Then we divide by 1 plus G RY. So that is the formula for modified duration. It is Macaulay duration divided by 1 plus GRY, which stands for the gross redemption yield. The gross redemption yield. We divide by the gross redemption yield. That's it. So we'll have workings. So first of all, calculate the Macaulay duration, which we saw in this lesson is equal to the sum of present value of cash flows multiplied by respective years. So Macaulay duration is equal to the sum of present value of cash flows times respective years. Okay, so this we divide by the market value of the bond. That's what we need to calculate the Macaulay duration. So we're going to have a working within a working. So we'll have a table here for years. You have years. How many years are here? How many years to maturity? It's 3 years. So you have 1, 2, 3. Cash flows. What are the cash flows? From the question, what are the cash flows? Let's read the question together. The bond A is a 6% bond maturing in 3 years. So 6% of 1,000, that will be the cash flow. That is the amount that will be received at the end of each year. That will be the interest. That is the cash flow. 6% of 1,000 shillings is equal to 60 shillings. So year 1, we have 60 shillings will be received. Year 2, 60 shillings will be received. At the end of year 3, the 60 shillings will be received plus the par value of the bond of 1,000, which is equal to 1060. Then we get we are going to have to discount these cash flows with the present value interest factor. What is the rate? What will be our rate? What will be our rate? What will be the discounting rate? Are we given the discounting rate? Yes, we have the gross redemption yield of 3.5%. 3.5%. So this 3.5% N. 3.5% N. 3.5% N. And given that 3.5% cannot be read directly from the table, we then use which formula? The 3.5% cannot be read directly from the tables. And therefore, we have to do it manually. The present value interest factor. Present value interest factor. The factor will be equal to 1 over 1 plus R raised to N for year 1. Year 2 be equal to 1 over 1 plus R raised to 2. Year 3 be equal to 1 over 1 plus R raised to 3. So this will be equal to 1 over 1.035 raised to 1. Year 2 will be equal to 1 over 1.035 raised to 2. Year 3 will be equal to 1 over 1.035 raised to 3. These are the present value interest factor. So I'll take my machine and divide 1 by 1.35. This is equal to 0.9662. Then I divide 1 divided by 1.035 raised to 2, 0.9335. And lastly, I have 1 divide 1.035 raised to 3, 0.9019. These are the present value interest factors. Present value interest factors, 0.9662, year 2, 0.9335, then lastly 0.9019. So what are the present values? Present values multiply, we discount these cash flows to be 60 times 0.9662, 57.972. 60 times 0.9335, 56.01. And lastly, I have 1060 times 0.9019 is 956.014. The next column is to multiply the present values times the time. So I'll take 1 times 57.972. The answer is 57.972. Next I have 2 times the present value there, 56.01 times 2, 102.02. Then lastly I have 956.014 times 3, 2868.042. The sum here, what will this total? Answer plus 1112.02 plus 57.972, 3038.034, 3038.034.834, 3038.834. So that is the value there. So we divide by the market value of the bond. So 3038.034 divide by the market value of the bond. What is the market value of the bond? Now the market value of the bond from the question, the last sentence there reads the current price of the bond is 1072. 1072. This is equal to 1072 point, is it 12? Point 1070.12. 1070.12. 1070.12. So what is the Macaulay duration? Macaulay duration will be equal to that value divided by 1070.12. I am getting here 2.84 years. That is the Macaulay duration, and that is the denominator here. The Macaulay duration is 2.84. 2.84 years. 2.84 years. We divide by 1 plus the gross redemption yield. The gross redemption yield we know is 3.5%. Converting to decimal, this is 0.035. So the answer here would be 2.84 divided by 1.035. This is equal to 2.74. 2.74 is the modified duration. All right? 2.84 is the modified duration. So a modified duration of 2.74, sorry, it is 2.74. The modified duration is 2.74. What does that mean? Now, a modified duration, candidates, and take this keenly, a modified duration of 2.74 means that for every 1% change in interest rates, for every 1% change in interest rates, the bonds prices are expected to change approximately by 2.7% in the opposite direction. For example, if interest rates rise by 1%, then the bond's price is expected to fall by approximately 2.7%. Conversely, if interest rates fall by 1%, then the bond's price is expected to also to rise by approximately 2.7%. Let me repeat, because the calculations may not make sense if one does not understand the meaning. What does it entail? What does it mean? Modified duration. We said in essence that modified duration translates the concept of duration into practical and widely used measure of bond price sensitivity. So a modified duration of 2.74, and candidates, this is not a measure of time, okay? It's a percentage change. So a modified duration of 2.7 means that for every percentage change, for every 1% change in interest rates, the bond's price is expected to change by approximately 2.7% in the opposite direction. In the opposite direction. You recall what we wrote here about the inverse relationship. We say that there is an inverse relationship between price of the bond and the yield. You understand? So it could change either way. That could be an increase or a decrease. So that if interest rates rise by 1%, the bond's price is expected to fall by approximately 2.7%. But if interest rates fall by 1%, the bond's price is also expected to rise by approximately 2.7%. That is the interpretation of modified duration, which is calculated by dividing the Macaulay duration by 1 plus gross redemption yield. Gross redemption yield. Gross redemption yield. And that's all for today's lesson. In this lesson, we have learned how to calculate the simple Macaulay duration and the modified duration. We've also in this lesson highlighted and discussed in detail the characteristics of both the simple Macaulay duration and the modified duration. Thank you for attending the lesson. I'll see you in our next session where we'll continue to share knowledge in advanced financial management. Bye-bye.